Good morning, everyone. Thank you for joining us for our session. I will turn our time over to Stu and Ali to give you more information about Neo4j Change Data Capture. Take it away, guys.
Thanks, Susie. If you just joined us, welcome to Nodes 2023, and hope everyone that's been here since this morning is enjoying the great content so far. Welcome to Building Event-Driven Applications with Aura and Neo4j Enterprise. We have an exciting session packed with product announcements, feature deep dive, and a great demo. So what is the cornerstone of an event-driven application? It's change data capture for a database. Up until now, Neo4j has had some custom ways of doing this with APOC, custom procedures, and our streams and connector plugins. All of these approaches present various levels of effort and challenges for the developer when building applications. So today, I'm excited to share that Neo4j has released a beta version of Change Data Capture. I'm Stu Moore, PM for Change Data Capture, drivers and connectors at Neo4j, and I'll be covering the why you need it and how it works in Neo4j. And I'm joined by
hello, this is Ali. I'm a software engineer in the connectors team, and I have been a feature lead for Change Data Capture. So I will walk you on a live demo to see how we use Change Data Capture to stream changes back from an Aura enterprise database. Back to you, Stu.
Excellent, thanks, Ali. We'd encourage you to put any questions you have in the Q&A, and we'll try and answer them as we go through the session. And hopefully we'll have time at the end to take some questions live. Otherwise, we'll hang around and answer questions for you later. Broadly speaking, there are three types of application that people look to CDC to solve. Building event-driven applications, the main topic of this session today, which is about detecting and responding to change in an efficient and timely manner, sending notifications to other connected data systems. Auditing, where we capture and record the before and after state, maybe who and what made that change, and replication, and sending that system information to other systems. This could be other databases, data warehouses, where you may choose to copy all or some of the data. Before we made CDC available as a beta, we ran an early access program for some of our customers. And I thought I'd take you through a quick summary of some of those use cases. They were keen to have like a robust, performant implementation of the database and a well-defined surface for their developers. Use cases included keeping other data sources up to date with Neo4j because it was the authoritative data source for information, or sending results from graph analytics to interested systems. This could include Elasticsearch for enterprise search systems, or feeding results into a reporting system like Snowflake. Others are creating applications that audit their application development in-house as they go through change control or security reviews, and managing identity and access management in buildings and systems. Lastly, one of our partners, GraphAware, has integrated CDC into Hume for their crime prevention use case. So how does Neo4j's Change Data Capture work? There are several approaches vendors can take in a database. We selected what is considered the state-of-the-art implementation. It's available in many other enterprise database systems like Oracle and SQL Server, because these systems are used extensively by our customers for relational workloads. They have a similar expectation for their graph database. We require no plugins or additional components to be loaded, and developers aren't required to request changes to the database schema, like including timestamps to identify changes, nor do they need to create cumbersome soft delete logic to handle deletes. There's virtually no overhead in terms of performance when it comes to just writing additional information into the transaction log. And in return, you get transactional integrity through the transaction logs and low latency response times and read scalability, as the API can read from the logs on the primary or secondary databases. There are three modes, of which the default is off. We write the same information as we do today in the logs. If you want to enable CDC, then you can use the create or alter database commands with the set option tx log enrichment mode, and then pass in diff, where we record the before and after state of what changed, plus some metadata. That's usually all that's required for most event-based systems. Or full, where we record all the information for the node and the relationships that changed. This may suit other auditing use cases or replication where you're sending data to other systems. What does the process look like under the hood then? Changes can come in from any source, that's Bolt, HTTP, drivers, connectors, or plugins. As the data passes through the system in the usual way, if one of the modes is enabled, then we write additional information into the store commands that create the log. The CDC module then reads the enriched entries in the transaction log, converts them to change events that can then be read by your application when it calls the CDC commands. Let's look at how applications interact with the transaction logs, because this is quite important for you to understand when you're building your applications. It calls procedures and retrieves the latest transaction event. Once it has done that, it needs to track where it is read in the log. This is known as a cursor, shown here with the diamond. As time passes, more events are written to the application log, and the retention time of the logs can be configured based on time and size of data. If the transaction exceeds that period, then it leaves the transaction log. This has implications for the availability of applications. If the application isn't running, then it isn't reading from the log, and the current transaction log will move nearer the end of the log as events get pruned. If the application recovers before the current transaction reaches the end, then no events are lost. If the application restarts after the elapsed time, then events will be lost. If application availability is a concern for the developer using CDC and the operations team, then Neo4j recommends setting the log retention policy based on time and size of the logs. This time should be greater or the same as the service level agreement and the recovery time objective for the application. So 12 hours log retention if that is your SLA. You should use historical trend data to understand the busiest periods of your database and the amount of log files generated in that time. Then size for additional 50% of data if you're using diff mode, or 75% for full mode, and ensure that available disk space exceeds the size of data generated in this time period. To ensure you don't get an out of disk event, you should configure the max log retention as well and configure appropriate monitoring and alerting. Alternatively, you can use systems like Confluent or Apache Kafka, which can consume the CDC events and then hold them in topics that provide the availability and create a loosely coupled eventing system to transmit the events to other applications. This is kind of like fan-out scenario. How do you query CDC? We provide three procedures. CDC earliest. This will help you retrieve the change identifier for the earliest change event in the logs. CDC current turns to one for the current committed transaction. Then CDC query that can be used to provide the change identifier to CDC and then return all the changes since that event. Your application needs to track which identifier it is read, and this is known as a cursor. I'll take you through a quick example. Ali will go through this in more detail as part of the demo. But when you call CDC current, it returns the ID shown here in white. This is the current transaction that has recently been written to the log. Calling CDC query, then, with that same ID, returns the change events which have occurred after this, and we'll explore the level of detail that you get over the next few slides. Selectors can be used and passed in with the identifier so that you can just focus on particular types of event, and we'll explore more of this later. There's the changed event identifier that's returned, along with some metadata. Here you can see that the start and end time, the transaction metadata itself from the app that has made the change, authenticated and executing users, the connection information, server IP addresses, etc., and the capture mode as well. And then you get the event itself. Here you can see that we've got an event type that was created for a node, and you can see the labels that were of interest that changed as well, artist, and the name and the properties associated. There's a before state, but no after in this situation because it was a create. Had this been an update, you would have seen the before information as well. To save application developers building all the filtering logic into their application and to help reduce the amount of data that they have to process, we have provided selectors. These enable you to register for the events that are of interest. For example, here we're just interested in the artists that change in our catalog. This kind of brings us to a second exciting announcement. We have the availability of an early access preview program for the Neo4j connector for Confluent and Apache Kafka. This brings essentially the same benefits to people wanting to build event-based applications using Confluent or Apache Kafka. You're no longer required to include the timestamps in your data model. You don't have to worry about soft delete logic. And you need only write simple Cypher patterns to select information for topics. We've based this pattern selection on the popular Streams plugin that we had available up until Neo4j 4.4. And we'll see more of this in Ali's demo. I'd also like to draw your attention to a couple of announcements we made earlier this year. We've extended our partnership as we continue to work with Confluent, and we've extended support for their Confluent custom connectors. This allows customers to bring their own connectors to the Confluent cloud, and Neo4j will support customers who wish to upload Neo4j Confluent connector and connect from Confluent Cloud to Aura. And we've got a couple of blogs on that. We also announced support for Amazon's managed streaming for Kafka, or MSK. You can use the Neo4j connector for Apache Kafka in AWS's managed streaming environment. So on our path to GA, we've been working with 5 customers and our partner GraphAware, as you've kind of heard some of the use cases that they're exploring. We're going into public beta now, and that's available in Aura Enterprise and Neo4j Enterprise subscriptions. We're making the Neo4j connector for Confluent available to select customers that we've been working with, and we may then take that out to beta early next year. I'm also pleased to announce that the GraphQL team are going to be releasing a beta of subscriptions for nodes that will be based on CDC. So that's really exciting announcement. So stay tuned on the GitHub repo for seeing that release. As part of the beta, we make some recommendations. I've touched on some of these earlier. Be sure to employ CDC using least privilege. That's documented in our documentation that's available. Plan for log growth around 50% for diff and 75% for full. Obviously, the actual amounts are going to vary based on your application data model and what's changing, but those are some good guidelines for you. Also, remember to set the size of the log retention as well as the time period as well, and that will help you avoid out-of-disk space. Secondaries, they provide the rescaling if you need it. This is unlikely to be required unless you've got lots of applications using the CDC APIs. And check out our docs. They include code sample applications in 5 of the official programming languages. And Ali, you'll be demonstrating one of those shortly. A beta, there's a couple of limitations to be aware of. When it comes to using selectors, just be aware that they're currently evaluated on the before state, not the union of the before and after state. So this means if you're using fine-grained selectors, e.g. for high alert, you won't see a change from low alert to high alert with a given selector. This is something that we're looking to change before we go GA. Schema index changes are not currently included in the CDC updates. We're evaluating whether this change is required, and we're looking for feedback on this during the beta. Currently, applications can only poll for changes. Streaming isn't currently available yet. And be aware that RBAC is not applied to the CDC events themselves. So a CDC application will see all data changes within the graph. But you can ensure that applications are only accessing it if they're required and authorized to do so through least privileged deployments. Note that enabling a CDC on a database that already contains data will only register changes from that point on. And we've provided a link to the feedback form. When these presentation materials become available, you'll be able to provide feedback through that. I'd now like to hand over to Ali for the demo. Thank you. Stop sharing now, Ali.
Yep, taking it. Hello everyone again. Welcome to the demo of Change Data Capture. In this demo, I will show you how Neo4j connector for Confluent uses our new CDC feature to query changes happening in an Aura enterprise database. For the demo, I'll be using Confluent Cloud with the custom connector deployed, but the connector is also capable of running in self-managed deployments of Confluent and Apache Kafka. Now let's head to Confluent Cloud Console and start deploying our connector. So I am on Confluent Cloud Console, click on connectors and just select the Add Connector button. The first thing here is to pick our connector plugin, which I will use a custom connector that I uploaded earlier. So this one. And we need to provide API access credentials for it to be able to communicate with the Kafka cluster. So I will enter those. Oops. Yep. And next is actual configuration for our connector. I will just use previously prepared JSON configuration here. Bear with me. Here we have some Neo4j access credentials that required for Aura enterprise connectivity. Then the first thing we need to tell the connector is how it would source the change data, and we say that it should source it from CDC. And we are stating that it needs to start from a user-provided cursor, which I will just go into Neo4j workspace and query for the current identifier, change identifier, and I will use this as value so that the connector will see changes from this point onward. Then we configure 2 topics to get change messages. The first one is the artist topic, and the connector will query for nodes of artist label, and anything matching that criteria will be published into the artist topic. Similarly, for the recordings topic, we have a relationship pattern as I highlighted on the screen. This will look for changes on recorded relationships that are established between an artist and an album labeled nodes. And we have a bunch of Kafka Connect configurations as well that says we will use Aura as the message format for the change messages. And I'll click continue. We need to set network permissions for our connector for it to connect to Aura Enterprise. Yeah, that's all required. We only require a single task, so I won't be changing this one. And we'll give a name to my connector and just start the deployment process. This will take a bit of time, a couple of minutes at least. So in the meantime, I would like to show you a console application that will check our changes. But before that, I would like to show you that what we have on the database, nothing at the moment. And I want to create two node key constraints, one on the artist label and another one on the album label. Having done our preparations, we can look into our console application. This is a very simple command line application that continuously queries for changes from the CDC and outputs that in a predefined JSON format to the console. This is exact same sample application that we provide in our documentation, with only one change I made, which is adding a selector, as I highlight here. Selectors are a way for us to specify which changes we are interested in. And here, what we say is we are interested in nodes with labels artists. You can define as many selectors as you wish, or just skip providing selectors, in which case you will receive all of the change events happening. So let's go build this program and just start running that. It is now active. And I will go back to Neo4j workspace and create an artist, an album, and link these together with the recorded relationship. So if we execute this, we have two nodes and a relationship created. And going back to the console, we will see the change event coming through. Despite we have created two nodes and a single relationship, we only have one change event just because of the selector we have provided. What information we have here, the change identifier, metadata about the transaction that made this change, transaction ID and the sequence of the change inside the transaction, and also the actual change that happened on the database. In this case, it is a node which is created with this element ID, with these keys, key properties values that are sourced from our node key constraints that we had created, and with the before and after state captured here. As highlighted by Stu, before is null because it's a create operation, and after reflects the state of the node that we created earlier. So let's look into Confluent Cloud and see if our connector has been up and running. As we see, it is running. And since we have created this artist node and also the recorded relationship, we should be able to see these in our topics. So first, I check the artist topic and look for the existing messages. Here we see exactly the same change data that I showed you on the console. Nothing different. This is an Aura message, and you can see the schema on the left-hand side as well. And if we look into the recordings topic, we will also see one message that describes a relationship now, which looks similar but have some differences. In the event part, we of course now see the event type is relationship. The relationship type is recorded. It has its start node and its end node identified by this element ID, labels, and keys as defined by the key constraints, and similarly the before and after states. We didn't have any key defined on the relationship, so it is empty. But if you have relationship keys, you will get those here as well. I think that concludes my demo. Thanks for listening, and I'm handing over back to Stu.
Excellent. Thanks, Ali. So we've just got a last couple of slides to take you through. And Peter has asked me what's been my favorite use case for CDC. That's a pretty tough one, but I think hopefully these next two slides will answer that question for you. So a couple of our customers who participated in CDC were kind enough to provide some quotes. So I think it would be unfair to choose between these two. So I'm going to say that Anil from Dropbox was kind enough to say that Change Data Capture enables us to synchronize the latest changes happening in our customers' various data sources instantaneously. Helps us guarantee that when they use Dropbox Dash, they will always be able to search and find their assets. And the second one, Christoph from GraphAware, the CTO, he was great at providing some excellent feedback on the product, and so was the Dropbox team as well. Graph data empowers modern law enforcement agencies to fight more crime and solve them faster. CDC will enable those agencies to react in real time to mission-critical events. For example, if the phone number of a person of interest pings from a cellular tower near a high-risk event where a VIP is present, an alert can be triggered to frontline officers. I'd like to thank both of them personally for being kind enough to provide quotes. I know it obviously takes something to get them approved through companies, so really appreciate that. So today we've really seen how Graph can sit at the heart of an ecosystem through whether you're building applications with GraphQL, building loosely coupled streaming pipelines with Neo4j connector for Confluent, whether you want to create your own event-driven business applications, improve the user experience for your users, whether they're internal in your organization or for your customer base. And we've also seen how you get more value from our partners' products as well, like GraphAware, who are offering exciting new capabilities. Just lastly, before we close out, I provided some kind of getting started material. You've seen that Lasse, one of our engineers who's worked on this as well, has posted the doc link. We've got some blogs on the developer blog. You can get access to Neo4j 5.13 on the deployment center and Aura Enterprise as well. And we've included a link to the feedback on CDC as well. So if you do take time to try out this feature and you want to provide us feedback, you'll be able to find the form there. So lastly, a big thanks from Ali and myself. We'll take any last open questions. Last thing I'd like to say is please fill out the feedback survey form. If you want your features improvement feedback accepted as part of the beta, then you'll have to give us a 5-star. But jokes aside, thanks again.